Hey, good morning, everyone. Welcome to HPC in the Cloud on this Friday morning. I'm Joe Schoonover from Fluid-Numerics here in Boulder, Colorado. So glad you could join us this morning. Today, I'm going to show you how to create an auto-scaling Slurm-based HPC cluster on Google Cloud. And I'll walk you through some basic customizations to help you make that cluster scale globally across Google's data centers. So yeah, let's hop right in. We got to start off with a little bit of prerequisites here. If you want to follow along with the demonstration today, if you don't have an account on Google Cloud, you can create one. All you need is a Gmail account to start, or a G Suite account if your organization has Google Cloud enabled for you. You can go to console.cloud.google.com and you'll be able to get a $300 trial credit that you can apply to today's tutorial and future tutorials that we're doing. Today you can expect that you'll spend no more than $5 and you'll be able to run some very simple jobs on compute nodes across the world. Once you have your account created, we're going to first enable the Compute Engine API. This will give you access to virtual machines and networking that you'll be needing to stand up your cluster. On the top left of my screen, you'll see I've got what the Google Cloud console looks like once you've got your account created. To enable the Compute Engine API, you'll want to start by going up to the top left corner, the little triple bar menu up there. That's called the Products and Services menu. You can click on that, and I've got Compute Engine pinned up top here, but on your menu it might be further down underneath Compute. You can click on Compute Engine, and the first time you come here, you'll see this little loading wheel for a minute, and then it'll ask you to enable the Compute Engine API. So it'll look a little bit different than what I'm showing you. But go ahead and enable it there. Once it is enabled, you should see a screen that looks like this. The other thing we need to do is set up what are called identity and access management policies. So when you have resources on Google Cloud, they are all protected by these policies that essentially align different roles and permissions with users' identification, and they're identified by their email address. In your case, it might be a Gmail account. For us, it's our fluidnumerics.com G Suite accounts. But essentially, what we need to be able to do is dictate what roles you're going to need today on your resources to be able to carry out the work in the demonstration. So you're going to need two roles, primarily Compute OS Admin Login. And this will give you the ability to SSH into your cluster and escalate to root privileges as needed. And then you're also going to need Service Account User. So once you have that Compute Engine API enabled on your side, to align yourself with those roles, you'll go to that Products and Services menu again, scroll down to IAM and Admin. Again, mine's pinned, but you'll see it directly underneath Products on your side. So IAM and Admin, we'll go to IAM. You should see a page that essentially has a listing of all the members that have access to resources in your organization or in your GCP project, and then what roles they have. To add a new set of roles for yourself, or if you're creating a cluster with other people today, you can add them here as well. You'll go ahead and add your username or your email address, and when you go to select that role, again, you're going to do Compute OS Admin Login. Now you'll see that there is a Compute OS login. The only difference between these two is that the Compute OS login is used for users you don't want to have escalate to root privileges. So if you're creating this cluster to give other people access to and you're going to administrate it, you might want to consider giving them Compute OS login to prevent them from escalating to root. But today, all the stuff we're going to be doing, we're going to need root privileges, so go ahead and use Compute OS Admin Login, and we'll align Service Account User. All right, and then you'll go ahead and hit Save. Now, I've already made my changes from previous tutorials, so I've got this little pop-up here, but you should see your account show up with the Compute OS Admin Login and Service Account User roles. So go back to that home page now. Okay, now there's really one more thing we have to do, but in order to do it, we have to actually have the G Cloud SDK installed on our local system. So the gcloud SDK is it's just a command line interface that allows you to control some attributes about your account and can manage your resources from the command line. If you want to install that and set it up on your local system, you can. You can just go to this link here, the cloud.google.com/sdk/doc/install. They have a number of instructions for a variety of different operating systems to show you how to get started. Now, if you don't want to install the gcloud SDK locally on your system, what you can do is, if you're on your Google Cloud Console, up on the top right, you'll see next to your user icon, there's a little button that looks like a shell prompt. You can click on Activate Cloud Shell, and this will open up a terminal window down at the bottom of your screen in your browser, and that will have the gcloud SDK already installed on it. So in previous times of doing this tutorial, I've shown folks how to align SSH keys using their own terminal on their local workstation. Today, I'm going to show you how you can use your Cloud Shell to align your SSH keys. So it'll be a little bit different than what I've done yesterday and in previous days, but it should get you off the ground. So what we want to do is on your local system, if you don't already have an SSH key pair, you're going to want to run SSH Keygen to create an RSA key. Now, if you're on Windows and you're using something like PuTTY, when you go to generate an RSA key, make sure it's the RSA type, and then also check the box to make sure that it's compatible with OpenSSH. As long as you do that, you should be good to go, and that should generate two files for you: a private key, which you should never share or put anywhere other than leave it on your system, and then the public key. And the public key is what we're going to actually use to attach to your what's called a cloud identity profile. So in addition to like your email address, the cloud identity profile aligns like Linux username, home directories, default shell, UID, GID, all the stuff you need to describe who you are as a user on a POSIX compliant system. So now, in order to allow you access to those virtual machines when you go to SSHN, you might be used to using passwords or some type of like a YubiKey or something like that. If you're already using traditional HPC centers, the way we authenticate on Google Cloud at the bare minimum is just using SSH keys. So we'll want to align that public SSH key with your account. Now, if you do want to do two-factor authentication, like using a YubiKey or something like that, OS Login, which is a service on Google Cloud, does have some features to allow you to do that. So definitely reach out to us if you're interested in setting something like that up. All right, so I've already created a key on my system, but what I need to do is actually get that public key into this gcloud compute OS Login SSH Keys add command. So if you have an SSH key and you've stored it in the default location, it'll be in your home directory under id rsa.pub. So you can snag that. Go ahead and copy. And then in your Cloud Shell, what you'll want to do is, let me see if I can make this font a little bit bigger. Yeah, it looks like I can. I'm on pretty small right now, so let's go to largest. There we go. We'll run gcloud compute OS login SSH keys add, and we're going to give it a key. So I know in the slide I have in the top right here it says key file. If you are using the gcloud command on your local system, go ahead and just use that key file and then give it the path to that public RSA key. If you're doing this in the Cloud Shell and you want to just use the key, just do -- key equals and then open up your double quotes and then paste that key inside of there, close the quotes, and then you'll hit enter. Now I've already attached an SSH key to my account, so I'm already ready to go, but at this point you'll want to run this command and you should be set up. So I'm going to go ahead and close that, and we'll move on to the next step here. Now that you have the SSH key attached to your account, you've got the permissions you need, we're ready to actually create a cluster. And what I'm going to show you is how to get started with our marketplace solution. This is a click to deploy, easy to use solution. It should get you up and running within the next 10 minutes with a basically you'll have a login node where you can go in and interact with the Slurm job scheduler and schedule workloads to run on compute nodes that are created like on the fly as needed. And then when they're done running your workloads, they'll be taken down for you automatically. You can just focus on doing your work. So you'll go to that products and services menu, and we'll go down to marketplace. And you can either look up Fluid-Numerics, you can look up Slurm-GCP, or you can look up the name of the product, which is Fluid-Slurm-GCP. I mean, I didn't even get all the letters in there, and it still came up. So we have 3 different base solutions available for you in Marketplace. At the top, what I call the classic Fluid-Slurm-GCP. It's a CentOS 7 based installation of the Slurm job scheduler. And we've also got some typical package management solutions for you. So when you launch this cluster, you're really going to get 2 nodes. You're going to get a controller that hosts the Slurm job schedule. It's going to host your home directory and another directory called apps. And this apps directory is NFS mounted to the login node and any compute node when they come online. The reason why that's important is because if you were to do all your package management underneath apps and then use the environment modules that we have available for you there, you'll be able to have just a very flexible package management system that will be available across all the nodes in your system. We also got things like SPAC. If you're using SPAC for HPC package management, it's really nice. You don't have to think about a lot of the dependencies for things like NetCDF, especially if you're doing like parallel builds. These things can get complicated, so we've included SPAC on these images, as well as Singularity. If your teams are actually shifting towards containerized HPC workflows, Singularity is there. We've opted for Singularity simply because, relative to Docker, when you go to run your HPC software underneath Singularity, you don't need to escalate to root privileges to run your jobs. And this is nice, especially if you're using this cluster in like a shared setting where you have multiple users on the system, and you want to do things safely, securely. So outside of that, we've got an Ubuntu solution, which is it's identical to the classic Fluid-Slurm-GCP, except it's got Ubuntu 20.04 as the operating system. And then we have down here the Fluid-Slurm-GCP plus OpenHPC, so it's the CentOS 7 solution that we have. Except we've included a number of packages that you can install from the OpenHPC repositories. So if you need very quickly out of the box things like NetCDF parallel serial builds, HDF5, MFEM, Scalapack, Trilinos, you name it. And most of these scientific software packages with parallel builds, FFTW is another one that comes to mind. All these are available on that solution out of the box, ready to go. So if any of those are in your dependency stack or you're using some of those packages directly, the OpenHPC solution is a good place to get started. For today's demo, I'm going to stick with our classic solution. And once you click through, you'll go ahead and hit launch. So now what's going to happen is I'm going to walk you through some of the basic configurations that we have available for you in the marketplace. If you're looking for something a little bit more complex than this out of the box, we do have a Terraform repository that has a number of different integrations that you can launch immediately, including some with Lustre file systems that will attach to your cluster, and file store for your home and apps directories. If you're looking to have a separate Slurm database with Cloud SQL, we also got solutions for that there. Now, the nice thing is about our solutions is even if you launch from Marketplace, we can customize it. I mean, any of these features we can customize after the fact, after your cluster is already launched. So really where you start becomes almost irrelevant. We do feel like this is a good spot to start because it's just quick and easy. Click to deploy. So we'll start with the deployment name. Today I'm doing a demo, so I'm just going to call this demo. This is just an identifier that's going to be used in Google's deployment manager to keep track of this deployment. It's also going to be the prefix on the names for the controller and the login nodes. Next, you'll want to choose the zone to launch in. Now, if you hit that drop-down menu, you'll see there's a lot of zones available. We'll talk a little bit more detail down the road here about zones and regions on Google Cloud. But essentially what you want to look for is something that's geographically close to you. And this is really to minimize latency between your system, where you're logging in from, and your login node and controller. Definitely check out Google's documentation. They'll tell you, the cities and states where these zones are. I'm going to go ahead and choose US West 1B. Today we're just going to be doing default networking. Now, if you do have to use non-default networking, if those networks are available in your GCP project, you'll be able to select them from this drop-down menu. So now let's pick the login node and the controller. So there's not a whole lot to think about on these. Really, what you just need to keep in mind is how many users are you trying to support, and then what kind of workloads are you expecting them to do on the login nodes. Now, generally, we expect on shared resources like this, on a login node, folks are probably just text editing, maybe doing some code compilation, just very lightweight work. But you might have, anywhere from 10 to 50 users who are all going to be trying to access your HPC cluster. So we've given you a few ways you can provide all the resources necessary to serve your user base. So you can have multiple login nodes if you wanted, and then you can also change the size and shape of those login nodes. So how many cores you're going to make available on each login node, and then how much memory. In this drop-down list, you'll see different prefixes on the machine type. So you see like N1 standard 2, E2 standard 2, N2, N2D. The N1, E2, N2, N2D all just reflect different CPU platforms. So like Intel Skylakes versus AMD EPYCs. Again, we're not going to go into too much detail on these today. We're going to stick with just N1 standards today. The one thing I will point out is we usually recommend a bare minimum of 8 virtual CPUs per login node. Keep in mind that a virtual CPU is just a hyperthread, so you're technically getting, with an 8 vCPU instance, 4 cores. The reason why we recommend the 8 vCPUs is that the network bandwidth, disk IOPS all scale with both. They scale with the number of cores you have available on an instance. The more cores you have, the more network bandwidth you could have, or the more file I/O bandwidth or file IOPS you can have. Up to a certain point, of course, there are limits. I believe on the N1 instances, once you get up to 16 vCPUs, the max network ingress bandwidth is 32 gigabits per second. There's a whole bunch of performance considerations really around the controller node. So the login node is just, you want to have enough resources available to meet the demands of your users who are just going to be getting in, text editing, code compiling, and interacting with the Slurm job scheduler. For today's purposes, I'm just going to leave this at the default of the 4 vCPUs on the N1s. If you did want to customize, if you hit that customize, you can actually pick a range of virtual CPUs. Right, up to 96 for the N1s, and up to 624. Right, and of course, if you change the series, so either N1, E2, you'll get different constraints there. But basic idea is you're not fixed to these standard types, which is really nice on Google. All right, now since the login node's not hosting Homer apps or anything special, you don't really need to have a boot disk size any bigger than what it actually is. And now the controller out of the box hosts home and apps. And if you plan to host your home directories and apps directories for the entirety of the cluster's life on the controller, definitely consider increasing the boot disk size to meet your storage requirements for your users. And if you have some heavy performance requirements, because you're also going to have, the Slurm database hosted on here, the Slurm controller daemon and the Slurm database daemon are going to be hitting the system if you have a lot of jobs going through, in addition to the work that your users are using. If you have performance limitations that arise because of heavy use like that, we definitely recommend just upgrading to the SSD persistent disk so that you don't hit the lower IOPS and bandwidth limits associated with the standard persistent disk. And of course, it's not just the disk size that ends up mattering. Of course, the more virtual CPUs ends up playing into this as well. Again, a lot of performance considerations when you really want to go into production, but to get you off the ground, we can choose something. And then the nice thing about operating on Google Cloud is as you run into these issues, we can change things on the fly. and you don't have to worry about long system downtimes or migrations, anything like that. It's really simple to customize after the fact. So again, I'm going to start with my 4 vCPUs just for what I'm doing today. I don't need anything crazy. Now we're going to configure our first Slurm partition. So if you're new to Slurm, partitions are a way to group collections of compute nodes that you want to have like fixed job limit times, or have some type of directed access for your users. So like maybe you have 4 or 5 different research teams, but you only want research team A and B using a certain subset of compute nodes. Partitions allow you to group those machines together, and then Slurm accounting together with that will allow you to align your users to whatever partitions you want them to use. When you launch your marketplace, you will get 1 partition, and you'll have 1 machine block in that partition. Again, when we get into cluster today, you'll actually see how to customize your 1 partition to add more machine blocks to it, so we can spread things out across Google data centers worldwide. We'll go ahead and give this partition a name. I'm going to call it demo. Now the next 2 variables are pretty interesting. We have static node count and the max node count. Now static node count is the number of compute nodes in this first partition's machine block that will be created with the deployment, and they will be there forever until you physically, I guess really until you go in and manually tear them down. Now those nodes, the reason why you might want to have static nodes is if you know you have workloads that are just constantly coming in, you'll be able to keep those busy. Static nodes are nice because you have no wait time at all for compute nodes to spin up, provided they're not already working on some other workload. The downside is that if you do have idle time on your system, you're going to be paying for those idle system costs. But we've included this in there to give you the option to decide how you want to run your cluster. Now the max node count, so everything from the static node count up to the max node count, all the compute nodes in that block of compute nodes are what we call ephemeral. And those ephemeral nodes are nodes that are created when jobs are submitted, and they're torn down when they become idle. So you don't have to worry about it. So this whole cluster will auto scale up to meet your needs up to this many nodes. We'll go ahead and just leave defaults here. But this gives you some flexibility to decide how you want to operate your cluster. And I mean, for us, we do a lot of R&D. We don't have 24/7 ops running all the time. We generally stick with a 0 static node count and then just have the max node count be whatever our max capacity is expected to be. And this way, I'm only paying for the login and controller node to run 24/7, which is minimal in comparison to these GPU accelerated nodes that we use. So it is nice to be able to just pay for the compute nodes that you're using. So again, you're going to choose a machine type. If you're doing tightly coupled MPI workloads, definitely go with the larger machine types, because basically when you're doing MPI communications on virtual machines on Google Cloud, ideally you'll have your communications in 1 VM. Now, of course, there are scenarios where you have a requirement of I need 1,000 cores or something crazy like that. You'll eventually have to spill over between multiple VMs. Just know that there's a little bit of a performance hit when you start to do communication across VM, much like the performance hit you would expect if you were doing MPI on premise on node versus cross node. So just keep those types of things in mind. We will have some tutorials down the road here talking more in detail about MPI workloads and high throughput computing workloads and how to choose your machine types. But today, just getting you off the ground, I'm going to pick standard 2, keep things nice and light for our demonstration. Now, if the zone you selected has GPUs, you'll see a GPU drop-down menu. You can have up to 8 of them. So if I select it, and then you see right now we have available on Google Cloud a range of NVIDIA GPUs that you can choose from. Now the GPU availability is related to what zone you choose out of the box here. Again, if you choose a zone for your login and controller that doesn't have GPUs, when you do the partition customization in today's tutorial, you'll kind of see how you'd be able to set up compute nodes in another region where GPUs might be available, but still have your login and controller close to home. I'm actually going to set this to none. I don't want to put GPUs on here today. But that's it. now that we've got everything set for our first cluster, you can go ahead and hit deploy. And while this is loading, let's talk a little bit about what's happening. So what's going on in the background is so our product is really something, it's based on what's called infrastructure as code. So we've written code that interfaces with Google. It tells it what to create and where to deploy it. So it knows to put it in your project. It knows to link it up with the network you've chosen and take those fields that you set in that form, give you the right number of vCPUs in memory for your login and controller nodes, and then take a schema that describes what compute node you want available and forward it onto that system. This is, I mean, you could think of this stage as like, this is your procurement stage, except you're not having to buy, you're not having to buy physical hardware. You're not having to install it, and you're not having to install the software. So the other thing that's going on here is we have images, virtual machine images that already have Slurm and some of these other packages installed. So when the controller login node come online, they are set up. They are ready to go. You don't have to wait any more than it takes really just to get these off the ground, which is anywhere between 30 and 90 seconds, at least for the CentOS solution. I think the Ubuntu solution might be more on the 2-minute side, but still, we're talking, what was used to be months or years to get, procurement done and all those resources brought in-house. We're taking all that upfront cost and we've reduced it down just to a couple of minutes for you. And then we've set you up with a system that you can customize over time and adapt to your organization's needs. What we're going to do next, once this cluster is ready, basically what this whole system's waiting for is a startup script to run to provision some of the specifics about your cluster, including the compute partitions you've selected. Now what we're going to do once this is ready is SSH into this system, and we're going to take a look around. I want to help you get a feel for how to see what partitions you have available, how to take a look at what NFS file systems are available to you, and so on. Now, there's a little bit of a quirk if this is your first time using OS login to SSH into a system on Google Cloud. By default, your Linux username is your email address, except we're going to replace the @ symbol and the dots with underscores. So this is, like I said, it's your email address, so it includes the domain by default. Now, if you're in a G Suite organization or using cloud identity, there are default settings you can change that will exclude the domain extension on your username. And alternatively, you can actually use Google's admin SDK in Python, or you can just use the web API to update your POSIX account user information. So you do have control to set your own username, UID, GID. If you're looking for help with that, definitely reach out to us on our help pages. I'll be giving you the email for that, but or even post something to the chat here. We'd be happy to answer those questions if you're interested. So as an example, if you are someone at gmail.com, your username would be someone_gmail_com. Now it looks like on our deployment manager page that we now have, the cluster is ready to use, and we noticed we got the IP address for the controller and the login. So what we want to do is, actually, let me pull up the Compute Engine page for you. So if you go to that Product Services menu, and we'll open up Compute Engine, you'll be able to see your compute resources that were just created. If you put in static nodes, you'll also see some static compute nodes here as well. We've got the login and we've got the controller. And again, there's those IP addresses that were also posted on the Deployment Manager page. Now for me, you can see everything right now is deployed in US West 1B. And when we get to this next step of looking around, we'll submit a job. You'll see a compute node come up in US West 1B as well. So what we want to do is go ahead and copy that external IP address. Okay, and you'll just SSH. So remember, again, your username is going to be, let's see here. Yeah, your username is going to be, it's going to include that domain to replace the @ symbols and the dots with underscores. I'm just Joe, so we have actually customized our Linux usernames with the admin SDK, and we'll put that IP address. All right, so now that you're logged in the system, let's take a look around. Now, Slurm has a number of commands available for you to interact with your cluster. First one we're going to look at is sinfo. This will show you the partitions we have available. So we got the demo partition. The asterisk next to it means it's the default partition. So if someone doesn't specify what partition to run in, this is where it's going to try to submit the job to. We got 10 nodes, all in this idle tilde state. Now the tilde just means that they are in a cloud state. And a cloud state really just means that Slurm knows that it can schedule work on them. They're just not available right now. They have to power up those nodes. And you'll actually see that happen here in just a minute. The other thing let's take a look at is the mounts. Just to reiterate the point too that, hey, home and apps right now are hosted on the controller. Now on our system, you are able to use other solutions. Like if you have your own NFS file server, could be in the cloud, could be on-prem, doesn't matter. As long as I have an external IP address in that and a directory on that is available for exporting to another system, you can host it under home and apps here. Not a problem. We won't be covering that today, but I think once you see what we'll do with some of the tools we have available for you, it's called cluster services particularly, you'll see how to make a lot of this happen. Okay, so the first thing we want to do before we submit a job is to basically align ourselves with the Slurm accounting. So if you are not aligned with Slurm accounting, you won't be able to submit a job unless you're root. But we don't want to do that. I do want to show you how to set up Slurm accounts so that you can set up your Slurm accounts and the accounts for others. So you're going to be using. I'll show you how to do this with cluster services. Now you can use the Slurm S account manager and handle it that way as well. We did want to provide another option, and the reason why we push cluster services is particularly because we've tried to reduce a lot of the cluster management really down to just defining a dictionary where you can tell me what Slurm accounts you want. You can tell me what partitions you want. Tell me what NFS file systems, Lustre file systems you want to have attached to the system. And you can just manage all that in a dictionary and use cluster services to set all that up for you. So to use cluster services, you will have to be root because it does it can do some pretty extensive things to your system. And the first thing we're going to take a look at is just showing what the current cluster configuration looks like. So we'll use a command called list all, and we're going to forward that output to config.yaml. So let's take a look at that YAML dictionary. It's got a lot of details in here. We do have the schema published on our help docs. If you go to help.fluidnumerics.com and check out the Slurm GCP page, you'll be able to find the entire schema completely described for you. So I'm not going to go over it in detail here. What we do want to look for is Slurm accounts. All right, there we are. Now, the deal is, by default, when you launch, the Slurm accounts is just an empty array. But this Slurm accounts is actually it's an object on its own, and we need to know the schema for that in order to fill it out. So we've provided a series of commands that will allow you to have sample blocks for your Slurm accounts, for your mounts, for your partitions, so that it makes it easy for you to make these configurations. So if you want to see what I'm talking about, if you did run the cluster services help command with a -h flag, you'll see all the commands listed that you can have, and then here's a description here. If we got sample Slurm accounts, it's going to provide a sample Slurm accounts YAML block to your standard out. So let's go ahead and run that. I'll show you what it looks like, and then we'll append this to the cluster config. Okay, and so you can see essentially what it takes to define a Slurm account. The way we've defined it is you need to tell me what partitions you want people in this account group to be able to submit jobs to, the name of the account, just so we can identify this group of people, and then the POSIX usernames or the Linux usernames that you have for those users you want to include. So what we're going to do is append this, so you can use the double right caret to append to config.yaml. Now let's open that back up. And now you see we've got that block down below. Let's go ahead and remove those square brackets, and I'm going to turn on my line numbering just in case that helps you guys follow along. Now the partition we want our users to submit to, I've only got one partition right now, so demo is all I need. We'll go ahead and clear that other one. Let's give it a name. I'm not going to be too creative today, so we'll just call this demo account. Now the users, my Linux username is Joe. I want to be able to submit jobs today, so I'm going to put myself in there. And who knows, guy might pop in and submit some jobs later. So I'll add him. All right, so this is looking okay. Now, highly recommend before you apply any changes. So all we've done is modified a local dictionary. Now we need to essentially get this through to set up, apply those changes to the rest of the cluster. Before you apply changes, we highly recommend always previewing those changes and checking your work. I mean, of course, if you make a mistake, we can always undo it. There's always a way to undo these things. But why not save yourself a little bit of work and just be a little bit more careful on the upfront here. So we'll say update Slurm Accounts. And to update the accounts, we need to tell it what cluster config file to use. And we want to use this config YAML that we're now working with. And we'll preview. All right. And all it's going to do is it's going to compare that config file we passed in here with the current cluster configuration and give us the difference. So here it says, okay, we got a new Slurm account. It's actually the first one in this dictionary. We're using zero-based indexing here. We're going to allow them to submit to the demo partition. The name of the account's demo account, and we got Joe and Guy in that list. Let's double check that I got the name of the partition right. So I have messed this up before, surprisingly, but it happens. It can happen to anyone. So we got demo on the allowed partitions. I think this is looking good. So now what we can do is just run that command and remove the preview flag and let it create users for us. Awesome. So now that we've got users, we can exit out of root and we're going to submit a test job. So there are three different ways to really get yourself some compute nodes. You can use salloc, which will allocate a set of compute nodes for you to run on. You can use srun, which will allocate the nodes and run what's called a job step. So just if you got a single command you want to run, you can use srun. Now, if you've got an entire workflow that's scripted, sbatch is probably the best solution for you there. For what we're doing, I just want to spin up a single task and have it return out the host name so that you can be convinced that, hey, I'm actually running this job or this command on a compute node. So we're going to use srun. We're going to specify -n for the number of tasks, set it to 1. Now by default, the number of tasks per CPU is set to 1. So if I were to say n2, it's going to try to run just going to run 2 tasks spread across 2 CPUs. We're just going to do 1. I'm going to go ahead and specify the partition. Now I don't have to because I know I'm running in the demo partition. But you know, I like to be redundant. And of course, if you have multiple partitions, you're going to want to specify that partition. And then the other pairing you need here is the account. And the accounting can get really interesting if you've got a lot of different projects your organization's doing. You need to segregate billing, and you need to segregate what compute nodes are available for what research teams, what have you. Slurm accounting can be really helpful for all of those things. And I guess in future episodes when we get to some of our more advanced configurations, we'll be happy to share with you all the nitty-gritty details of Slurm accounting and GCP project management, partition management. Anyways, I tend to get sidetracked on these morning ones. We'll set the account to demo account, and we're just going to run hostname. All right, so it looks like nothing's returning right now, but if we go to the Cloud Console on that Compute Engine UI and hit refresh, you'll now see demo 0 is coming live. This is one of our compute nodes. It's spinning up in US West 1B. So what's happening? Because all of our nodes are ephemeral, and they're in that idle tilde state, they're in a cloud state, the controller essentially said, okay, I got a job to do, and I need a node, so it went and made some calls to Google Cloud to spin up that compute node. And basically that compute node is doing the same thing that the other nodes did when they were brought online. Google is providing cores, memory, disk space. It's going to launch our virtual machine image on that compute node, so you'll already have the Slurm daemon and then all the other necessary components in place to auto mount the home directories, the app directories, so you have that sort of consistency between what you're seeing on the login node and the compute nodes. All that stuff's being done for you. Now, this stage can take anywhere from 30 seconds to 90 seconds for our CentOS solutions. And as I mentioned before, on our Ubuntu solutions, we've seen up to 2 minutes to get these off the ground. But you could think about this like, typical job queue times on your on-premise systems, even in things like debug queues. Now, the cool thing is, if you have a sufficient quota, and the data center, I mean, I'd be surprised, but life is full of surprises. But if the data center also has capacity, you can spin up as many nodes as you need to on the fly. So essentially, if you're trying to serve, 10 to 50 users, they can all have these very short wait times. Now, the upshot here as well is once a compute node is live, so long as it hasn't been torn down yet automatically, you'll be able to submit jobs back to those compute nodes over and over and over. Now, there is a setting that we have on our cluster where you're basically able to change the amount of time a compute node is idle before it's torn down. So let me first demonstrate this point. Now that the compute node's up, if I ran that job again, it comes back immediately, right? If I changed the number of tasks to 4, it would spin up 4 nodes. I'd have to wait for those other 3 to come up. But again, it's like 30 to 90 second wait time. And as long as the node's up, I can get immediate response. Now, if you did want to play around with that setting, so how long those compute nodes are made live, you can just change that suspend time, and then you'll just run a cluster services update all on your cluster, and that will update the cluster settings for you so that those nodes are taken down. Right now, it's 300 seconds. You could increase it if you want them to stick around a little bit longer. We've given you this tunable parameter, again, really just to meet the needs for your organization. I need to get out of that. So we've got a compute node live. What do we want to do next? So now the deal is everything right now is running in US West 1B. Now, what I want to show you is how to take that partition we have and spread some of these resources out across multiple zones in the same region. And once we get through the practicalities of how to do that, we'll talk a little bit about why you might want to do that on the other side. So first, whenever you're making partition changes, you'll need to be on the controller to make those changes. So we'll go ahead and log out. Okay, we're going to copy the external IP for that controller, and let's go ahead and SSH in. Okay, again, we got our login screen, Slurm logo there, so you know you're in. And because the home directory is hosted by the controller, you'll see that same config file that we were using before. Because we're going to use cluster services, go ahead and switch to root by running sudo su, and let's open up that config file. I know I use Vim. I know there's like a fine line between the Vim and Emacs folks out there, and then the Nano folks as well. My apologies if I've offended you. Let's go ahead and turn on some line numbering here just to see what we have here. So what we want to work with is the partitions. So down on line 21. The partition has, in addition to the machines block, which is an array of objects here we'll get into in a second, you have some other items here like the labels on these, which is nice for one way to segregate like billing charges, or if you're doing some type of monitoring. Labels can be helpful for doing different queries across all of your resources. And then we've got the max amount of time users can submit to this partition, the name of the partition, and the GCP project we want to align it with. Just a short note on the project there. If you have a need to segregate billing across compute partitions, so like if you want to run one centralized cluster, but you have 6 different grants that you're working on, and you need to have separate accounting for like directly allocable compute costs, using separate projects on your partitions is actually really useful because you can actually use the project identifier in your billing reports from Google to break out all those charges and figure out what the directly allocable costs are to different grants. Anyways, fun accounting stuff. I would call it the boring but very important bit of details. Actually, you know what? I take that back. It's not boring. It's actually quite a bit of fun to engineer these systems to do all this stuff for you automatically. Anyways, we're here just to mess with some machine blocks in these partitions so we can go multi-zonal. So what we want to do is copy lines 25 through 39. We're going to take that machine block and we're going to add another machine block down below. And all I want to do is change this from US West 1B, let's say, to US West 1C. Now, the deal is right now we have a name conflict in the machine blocks. You do need to have compute nodes with distinct names. So what I'm going to do is just call this demo US W1, W1B. And then I'm going to call this one demo US W1C. So that's it. All I've got is I've copied the original machine block, I pasted it down below, set the zone to US West 1C in that second one, and I'm updating the names just so that I don't have any name overlaps in these compute nodes. Again, we're going to run cluster services update. What we're going to update this time instead of Slurm Accounts is partitions, and we're going to give it this local config file. And do not run that just yet. We're going to preview it first. Okay, so you can see the preview detected, all right, on that first machine block in that first partition, we have a name change. So anything, these demo compute nodes will no longer be tracked by the Slurm controller. And then we have partition 0, we've added a machine block. And that machine block is named demo US W1C, and we're deploying to the US West 1C zone. So this is looking okay. Let's go ahead and apply that change. And then we'll need to take care of one other thing before we get back to submitting jobs. Okay, so now if you run sinfo, still got the demo partition as our default. And now we've got 20 nodes in an idle tilde state. Some of them, 10 of them in US West 1B and 10 of them in US West 1C. Now back on your cloud console, you'll see that demo 0 is still up. Now this node is no longer under the supervision of the controller. If it's still up on your side, go ahead and check the box next to it. Make sure you're checking the box next to that compute node and not the controller or login. And we'll hit delete. Okay, that way you're not paying for any stale resources that are just hanging around. Let's go ahead and go back into that controller. I'm sorry, we're going to go back into the login node. And again, sinfo shows us, hey, we've got these 20 nodes available. So now what we're going to do is we're going to run another job. Let's see if I can get it to come back up here. There we go. I want to run 2 tasks. And this time, I want to show you another flag you can pass into either srun, sbatch, or salloc. You can give these commands a node list. So if you had a specific zone you wanted to deploy to for some reason, there might be a data center outage, or a data center might be at capacity at the moment, and you want to quickly switch over, you can say node list equals, here we're going to say demo USW1 B-0, because really what I want to illustrate for you right now is I want to run one task in one one zone, and I want to run the other task in another zone. So say demo USW1-C-0, and we're going to run the host name. So let's go back to that console, give it a refresh, and there you go. We've got one task per node running in West 1B and one task running in West 1C. So why would we want to do this? So let's back up. Google data centers are worldwide. I mean, they're on every continent except I think Antarctica. And the data centers that are geographically close to each other are what are called, they're said to be in the same region. And then within a region, you have 2 or more zones, and a zone is really just a specific data center. Sometimes data center outages occur. Sometimes there are capacity limits, and you know, it's nice to have a quick and easy way to spill over into another zone, or you might have just some capacity like requirements just for yourself where you have to spread across multiple zones just because you're such a, you're an HPC power user. This is one way to get yourself access to more resources, is to basically expand across one data center. We highly recommend whenever you set up a cluster, have that sort of high availability configuration where you can easily, quickly spill over to other zones. While we wait, I'll just let this play here until we have some response back from these compute nodes. This was actually from a simulation we ran on 8 V100s on Google Cloud. And we did some of the rendering with Visit, actually, for this one. This is just doing some really fancy fluid simulation stuff with Navier-Stokes. Anywho, let's get back to business here. The compute nodes have responded. We've got demo USW1B and C printing back their hostname for us. And again, since they're already online, I can submit jobs and I get immediate response. All right, so what we want to do next is, we got multi-zone. Let's go multi-region. What if I wanted to go to have jobs spread across the world? We've made it really easy for you to be able to do that. So to make that happen, again, we need to go back into that controller. So let's do that. Make sure you're in the controller. You'll see in your shell prompt the name of your cluster -controller. So open up the config YAML. We're going to do the same thing we did before. We're going to copy an existing machine block, and then we're going to modify it. So let's take from lines 40 down to 54. Let's take those 15 lines, paste them below. All right. Now we got our 15 extra lines. I'm going to put this one in Europe. So US West 1 is over in California. Europe West 1 is in Belgium. Let's have some nodes spread between California and Belgium. So we'll call this EU West 1B. I'll set the zone to Europe West 1B. Now, if you're using default networking, the other bit of, actually, no matter what kind of networking you're using, you do need to change your subnet if you're changing regions. And the reason why this happens is the way networking works on Google Cloud is, when you would deploy compute resources, they have to be deployed within a subnet, and a subnet is tied to a specific region. So if you're using your own networking, make sure you have a network in Europe West 1 or whatever the other region is you're submitting to. If you're using the default networking, you can just make this one simple change. On the VPC subnet line, you'll see a URL that points to that VPC subnet. You'll see it has the project ID. So, if you have networking in another project, you do it there. So if you're using shared networking. Anywho, regions, and then you got the region over here. So again, for the default networking, this is really simple to do out of the box. All right, let's go ahead and, whoops. I did not go root, did I? Let's fix that. Goodness gracious. I am just being hasty this morning. Set that number. Again, let's get those 15 lines. Hey, seeing it twice never hurts. So again, we're going to change this to Europe. I think the other problem is I'm a little caffeinated this morning. So the error rate on my side is a little higher than usual. All right, so we got the zone change. We want this West 1B, and that one's Europe West 1B, and then we've got the VPC subnet using a region in Europe West 1. All right, now we're in business. Let's pull up that cluster services command, and we'll preview. So now it wants to basically add this third machine block into that partition. Again, the name demo EUW1B. We got the subnetwork set in the Europe West 1 region, and the zone is Europe West 1B. So I think we're good here. We'll go ahead and apply this change. And we'll take a peek here once it's done. All right, S-info. Got to remember the N. All right, so now if you update compute partitions and you retain some of the existing nodes, we have cluster services actually go through and spin down any nodes that are live at the moment. And the reason why we do this I mean, it's really needed to refresh this whole system. It's just part of some of our best practices here. So when you go to update partitions, make sure you're doing it during a system downtime. As you see, it only takes like 5 minutes, but definitely notify your users in advance. Give them some time to complete their work, and then run through these kinds of changes. Now, the cool thing is if you put your cluster config under version control, you can use like Git flow development strategies to plan out all of these potential changes. This will be a subject of another tutorial we have coming up down the line, continuous integration for these clusters. Anywho, the deal is, these guys are coming down now. So if I were to refresh the console here, they're gone. And now what we want to do is get back onto the login node and run another job, except now we want to run a job across multiple regions. So if I bring up, let's see here, actually, let's do an sinfo so I know what node names I have there so I don't botch this. All right, now I want to run 3 tasks. Still want to run in the demo partition with the same account. Because the US West 1B0, West 1C0 nodes are actually being powered down, which is what's indicated by that %sign. They're still red, the Slurm controller daemon is still catching up with the fact that they're now gone. And so let's change these to 1 because we have more nodes in that machine block. And then we'll say demo EU W1B0. All right. And then we're just going to run the host name again. Same sort of deal. What's going to happen in the back end is those nodes are going to be provisioned. So here you go. We've got Europe West 1, US West 1B, and US West 1C coming online. While we're waiting for this to be created, let's talk about why. Why would we want to do this? I'm not going to repeat the same caveat here. You know already, data centers are grouped into regions. Now, you might be in a scenario where you're running high throughput compute jobs. You've just got a ton of data to process, and you need to spread across multiple regions. Or, you might, for those of you who want to use GPUs and your controller login are not in the same region, you might need to have some compute nodes in regions where certain GPUs are available. Whatever the reason is, we've given you the ability to quickly and easily, as you've seen, spill over to multiple regions on the fly. You can customize all of this as you go. Now, there's some caveats to this. When you have communication between different regions, you're definitely going to see a latency increase in communication from region to region. And the way you'll see that here is you'll see that the Europe node is actually going to report its hostname last every single time. And it's just simply because there's just a lot more physical network infrastructure for communications to happen over. So, for example, if you're doing MPI jobs, we definitely don't recommend doing tightly coupled MPI jobs spread across multiple regions, simply because you're going to see a massive latency hit in like point-to-point or all-to-all communications especially. That being said, you can have, one tightly coupled MPI job running in US West 1, one tightly coupled job running in Europe. And this could be, you might need this for capacity reasons. If you're doing something like that, the other thing to be aware of is that network latency hit that you take for inter-region communication, it affects file I/O performance as well. So if you have your home or apps file servers or wherever you're writing your data out to or reading from, if you have them in different regions, you're going to see a hit in your file I/O performance. So in these types of scenarios, we often recommend having, if you need to have a file server available for your jobs, have them in each of those regions, and then have some mechanism to replicate data between them, just so that you can have data near those compute nodes or nearest to those compute nodes as possible. So in general, just a best practice, keep those tightly coupled MPI jobs running within the same region, ideally within the same zone. Google has some great blog posts on some of these details for MPI applications, especially. I highly recommend you look them up. Just check out the HPC product pages for Google Cloud. Now you can see, though, everything's responded back. And as I said, the Europe node responded last. So if I run it again, the job goes through immediately. But Europe always responds last because it's the furthest away. Waiting for resources. There it goes. jumping the gun a little. All right, so I've shown you how to get your cluster up and running. I've shown you how to get multi-zonal partitions and multi-regional partitions. You're ready to start scaling your HPC jobs globally. So if you're done with the demo and you're done with this cluster, I'll walk you through what it takes to tear it down. If you're going to keep this cluster running, you're done. Of course, if you have questions on any further customizations, definitely ask them in the chat room or reach out to us. Quickly, I'll show you how to spin everything down. I'm going to pull up that srun command just so I can quickly fill in those node names. We're going to use scontrol, which is a Slurm binary that will allow you to control different compute nodes in your cluster. So we'll say sudo -i to forward our environment so that scontrol is still in your path. We're going to do update node rather than node list. We'll give it those nodes that are currently online, and then we're going to change the state to power down. So this is how you, if you wanted to direct a node to be powered down, this is how you could do it. So if we run that, let me pull up that cloud console again. It looks like it hopped off my screen here. Let me grab that back up. There we are. Okay. Yeah, so now you can see those are all being spun down. Now the other thing you'll want to do is go back to that deployment manager page and hit delete, and that will tear down your login and controller nodes. So I know I went a little bit over time today, but I do appreciate you sticking around. Just a few more items here. If you do have questions, feel free to start asking those now in the chat window. I'd be happy to stick around for a few minutes and answer your questions. While I wait for your questions to roll in here, I did want to just make a couple plugs for some of our community content. If you ever need documentation on how to get started with your cluster, we do have our help docs up at help.fluidnumerics.com/SLRM-GCP. Underneath there, you'll find a ton of resources, including code labs that will walk you through some of the stuff we did today, including the multi-zonal, multi-region partition setup, in addition to some of the stuff we're going to be talking about next week, which is package management, where we've got a series set up for you where we're going to talk about all the different ways you can manage packages on this cluster. There's just so much flexibility you have once you hop into a cloud environment, and we want to kind of walk you through all the different strategies. You'll start to see some of those code labs. We do have some already for the Python package management on these clusters, but we'll be populating some more in there in the future, and of course doing these on the live stream for you. If you ever need support, you can always reach out to Fluid-Slurm-GCP at fluidnumerics.com, and we are there ready to help you make sure you can get up and running, get off the ground very quickly. Of course, I ask that you join us again. Subscribe to our YouTube channel. You can check out our help pages. You'll find the live community training page. We'll have more information about upcoming talks we'll have. In general, you can expect me to be here every Thursday at 4 p.m. Mountain Time, and Fridays at 9 a.m. Thanks again for joining. We really appreciate having you here. We'd love to see what you're using our solutions for, and we'd love to get you started with